So really, for my talk today, I just wanted to talk a little bit about ClickHouse. What is ClickHouse? Provide a little bit of an introduction to OLAP and ClickHouse. It's not widely known within Australia. And why is ClickHouse so popular? And where did it sort of come from? So I think for my talk today, I was going to talk about a little bit about ClickHouse and how that's evolved into the Australian market here as well. A little bit about me. I'm a solutions architect, just joined ClickHouse recently, coming from a big Kafka background and a data analytics background. So I'm 2 months in. Please take it easy on me when it comes to questions. We do have Jeremy in the back corner who can absolutely help to run through some of that. So that's me, based out of Sydney, Australia as well. So what is ClickHouse? ClickHouse was formed back in 2009, an open source back in 2009, and it's been one of the fastest growing sort of open source projects around, grown quite significantly. There's over 33,000 GitHub commits on there and stars on there when it comes to GitHub contributions and stars, and lots of several releases have been released. So it's an open source product that was formed back in 2009. And it's based on this column-orientated, it's really hard to say, columnar-based database where everything is basically, every single column is stored in its own file within the file system. So it's a little bit different to your standard OLTP or your transactional database. It's really optimal for building aggregations and running real-time aggregations against lots of data, whether it's millions or even billions of rows per second. So quite powerful to be able to ingest and query data in a fast manner. It's great for things like group bys, for analytics, for running against different filters as well. And because of the columnar-based database and how it stores the columns within its own separate files, it's great for inserts as well. So as the data gets inserted, all the columns get broken out and stored into their own individual files and grouped by that particular file. Also really good for deduplications, because as the columns are most likely they're very similar and they're stored within a specific file, a lot of that can be deduplicated and you get sort of like a 10x type compression there as well. ClickHouse is distributed, so you can have lots of ClickHouse servers. One of the biggest clusters that we know about, I think, is about 4,000 servers. They're quite large, running lots of analytics across the cluster there. It can be deployed sort of in one big cluster. You can run it on your laptop, or you can have multiple shards and replications. You can run across multi-AZ, multi-region as well, to be able to have one big ClickHouse cluster to run all of your analytics. And it's also based on an OLAP sort of terminology. So it's for online analytical processing. A little bit different to your transactional databases where it's OLTP or transactional based databases. It's based on OLAP, so online aggregations. It's really meant for calculating aggregations against millions or billions of rows per second. And that's kind of where the OLAP foundation, the OLAP came out of that particular form. And here's a really good sort of representation of that. Awesome. So on the left there, we've got a traditional OLTP transactional database, and you can see that it's row-based. So every single query has to scan every single row to be able to find the column that it's looking for. And that can take a long time, especially when you're processing millions or billions of rows per second. With an OLAP database, what it's actually doing, because it's stored every single column in its own file, it doesn't need to scan every single row. It just scans the columns that it needs to search for, and it runs aggregations against those columns. And the performance on running a columnar-based storage is tremendous in terms of being able to process and ingest millions or even billions of rows per second. So it's quite powerful to be able to do that on the bigger stuff. Okay, sorry. So what are the key features of ClickHouse? So really, ClickHouse uses standard SQL. So it's very popular to be able to run SQL's out there. It's been used for lots of different use cases. We're starting to see SQL being used in observability use cases now for search, for investigation, to create dashboards on observability. So SQL is now becoming almost like the new standard for observability, obviously for online processing, for analytics. It's using standard SQL. There's standard UIs and editors that have been used, whether it's observability or analytics or building out data, but it is based on SQL, including the inserts. So when you're inserting data, you're inserting using an insert statement, very similar to SQL. Can process lots of writes on a single server as well. So that's kind of, because it's a column-based database, on a single server you can process thousands and thousands of rows per second. And it's kind of built on that. So it's built based on that storage system, which we'll talk about, the merge tree sort of storage engine, to be able to create those files and then merge those files as well. ClickOut is distributed, so very large deployments. And it's also got highly efficient storage there as well. So once again, because it's a columnar-based storage, everything within those files gets compressed and deduped. And there's different codecs that ClickHouse uses internally to get better efficiency and better deduplication out of that storage and those files there as well. Also, from a querying processing perspective, ClickHouse uses sort of a distributed formula to be able to distribute its query across the different servers and basically use different tasks and different processes and sub-processes to run concurrent queries, basically using as much of the resources possible to run those queries simultaneously and as fast as possible. So very fast processing in terms of querying and processing. And then also, ClickHouse supports all the common things like joins, updates, deletes, all of the common SQL type functions that exist within SQL. So just a few little customers that I want to talk about that contribute to use ClickHouse for different use cases. It is based on an analytical use case, but there's multiple different lenses you can apply on those use cases there as well. So user-facing customer analytics, where you want to provide statistics back to your end users like Spotify and those sort of customers, that when you're interacting with the application directly, that application's interacting with ClickHouse at the back end, providing those real-time analytics back to you as a customer. So every time you're on the Spotify app and then you look for some statistics, a lot of that comes directly from ClickHouse. ClickHouse is used a lot for internal analytics and BI and analytics. So typically we see ClickHouse used for both, whether it's dashboarding or BI and analytics dashboards, where it commonly sits on top of a data warehouse, where providing that speed layer where the data warehouse cannot keep up with the concurrency of users that it needs to use to access those databases internally or that data internally. So a lot of internal analytics and BI type use cases are very common within ClickHouse. And observability. One of my favorite use cases is the Cloudflare use case, where they're looking at every single HTTP and DNS record coming through their Cloudflare service, and they're analyzing that information in milliseconds worth of time to be able to query that data. Not only are they using it internally for their own internal observability, but they're also providing those statistics back to their external customers so that the external customers can view within their dashboard how they're accessing their Cloudflare service, how many DNSs are getting blocked or what domains are getting blocked, what are the HTTP requests, like all those sort of things. They're providing that back out to their end users via ClickHouse to be able to see their DNS service through Cloudflare. So it's quite powerful in those use cases. So ClickHouse being coining the term of being the fastest database, we also provide our own benchmarking tool that's completely open source called ClickBench. And it's available on ClickHouse ClickBench. You can go and download that and then run the database comparisons against ClickHouse versus other databases for specific workloads. And anybody can go and access this website. You can go and contribute to that if you wanted to run your own workloads or your own performance tests. You can do that with ClickBench, and then you can run that against different databases, run the exact same test across your different database or the ClickHouse database to see the performance benchmarks that you would get from ClickHouse. So ClickBench is a great tool to be able to see that against that comparison against other databases. Also, from a storage perspective, being able to compare your raw storage versus your compressed storage and seeing the compression of 90% less hardware in eBay's particular case to be able to store and run those searches. ClickBench is a good tool to be able to show some of that there as well. So ClickHouse is no different from any other SQL-like engine. Very similar. So when you're creating a table, it's a very similar statement, create a table. You've got your standard formulas defining schemas, for example, whether it's string or integer. There's some different functionalities there's lots of functions in ClickHouse, things like low cardinality, which is a really popular one. Being able to basically have a field that's got lots of values in it. You can sort of create a low cardinality string against that. And what that will do is basically just group by and create a number essentially and an integer against that particular string, saving some space. Things like map functions, array functions are quite popular. And with ClickHouse, the main difference when it comes to ClickHouse versus traditional SQL is the order by clause or the primary key clause. So with SQL, traditionally you define a primary key. With ClickHouse, it's more of a sort function than it is a specific primary key. So what we're looking for is basically an order by that looks within a sparse index within ClickHouse to be able to determine where the particular key is that it's looking for within that order by statement. So it's kind of like the primary key, but it's more of a sorting order. And finally, the engine. So ClickHouse is built on this merge tree type engine. And a merge tree engine is like a log structured merge tree that's been around for a while. ClickHouse has taken that one step further to be able to basically create, as you create an insert, the insert creates a hash. That hash basically will go and write to a particular file on the disk. Then the next insert that comes through will write another file to the disk. As the files get written, they get merged into bigger parts or bigger files within the particular system. And that's basically the basics of what a merge tree engine is, and gives ClickHouse the power to be able to ingest really quickly and also query that data really quickly as well. There's different types of merge tree engines. There's things like replacing merge tree or collapsing merge tree. So if you want to remove duplicates, for example, you might have a whole bunch of inserts that have duplicates. You would use something like replacing merge tree, where it would go and dedupe the data, essentially. Or things like collapsing merge tree, where you can go back and delete or update fields within the particular tree there as well. One of the really powerful ones is like the aggregating merge tree, to be able to aggregate or sum or aggregate data as it's being ingested, which is quite powerful. So the engines are what really make ClickHouse so powerful. And also there's several integrations. Kafka and MySQL, Postgres, and S3 are probably the most common integrations out of the box that we see with ClickHouse. Obviously there's libraries like Go and Python and .NET and Java and REST interfaces as well. Things like RabbitMQ, JDBC and ODBC for anything that's got a database connection. These are all out of the box and functions are already available within ClickHouse that you can use straight away. So we spoke a little bit about merge tree and how inserts occur. So with ClickHouse, there's two types of inserts. Typically, it's very batch oriented. So everything needs to be batched. Well, ideally, it should be batched. The bigger the insert, the better. The more the rows that you have will create a file or a part within the system. So if you can batch as many records into a particular insert as possible, that's going to create a bigger file, which will then get merged. Obviously, the less files it has to merge, the quicker it will be. So that's quite powerful. But also, there's also a release now that's enabled. It's something called async inserts, which is kind of like you can asynchronously insert data into ClickHouse, and then ClickHouse will keep that data in memory for up to 200 milliseconds by default, I think it is. And then it will batch the data and write the files into disk. So now that supports things like streaming, where when you want to ingest row by row type data as well. So it's great for both batch use cases and also streaming use cases too. Now with async inserts, they're quite powerful to do that. And there's also some external integrations. I mean, you don't even have to insert the data into ClickHouse. You can read the data directly from S3 or from a file or even from MySQL. There's a whole range of functions or table engines that you can go and select star from S3. And then that will go and pull back a particular data set from S3 with the wildcard there as well. And the other thing is it will also infer the schema, which is quite powerful. So it will try and guess what the schema type is. Is it an integer? Is it a string? Is it a map field? So ClickHouse is quite powerful to do that. So you can read the file directly from external sources, or you can insert the data directly into ClickHouse. So it's quite quite powerful. You can see that statement there. So you can insert from a select statement. So basically you're selecting from an S3 bucket, you're reading all the data from S3, but you want to insert that into your table to make it more performant, get all the benefits of merge tree with the faster performance and being able to have the dedupe and compression on that there as well. It's quite powerful to do that. I know I just said select star. It's not really the best approach to use ClickHouse. So it's really good for investigation. Obviously, we run that and we want to look for data. Select star from table. That's a very common standard. I do that all the time. I'll put my hand up and say that I do that. But it's not the best approach for ClickHouse. ClickHouse has to read the whole data, every single row, every single column to run that table, to look for everything back in there. It'll still do it. It's still very fast. And it's not the best use case for ClickHouse, but it is good. And similar to where you want to read a single row. So if you want to say where row ID equals XYZ, that's got to read row by row and it's got to find every single row. It'll still perform very well for investigation, but if you need sub-second queries, that's probably not going to be the best query to run for that use case. Where ClickHouse does really shine is to be able to run aggregations or OLAP type metrics across a large set of data. So if I want to select the average or the sum or standard deviation of something from a table where the year is 2022. So I'm looking across all the data from 2022 and I want to create an average or a sum of that particular table. That's where ClickHouse really shines. Being able to create those reports in sub-second sort of latency to be able to pull that back and then query that data. Okay, so on top of the data, so we've spoken about merge tree, we've got some inserts of data coming through. Then ClickHouse has another concept called views, and there's a couple of different types of views. There's really two sort of most common views that are used in ClickHouse. So the first one's just a standard view, which is basically just a save query. So you've written a query, you really like it, you want to use it again, you want to share it out with other people. You can save that as a view. It's very similar, so create view as view name, for example, and that's a view that you can reuse and it will go back and select from a particular table. Quite good, quite powerful, very handy. Where ClickHouse is really powerful is being able to create what we call a materialized view. And a materialized view within databases is not a new concept, but it's a bit different in ClickHouse. So traditional databases, when you create a materialized view, it's almost like a batch process. I've even seen customers use cron jobs to go and run that particular materialized view to pull the data back. So there's a bit of a latency sort of batch association with materialized views. With ClickHouse, the way it kind of works, coming from a Kafka background, it's like a string process. So as soon as you insert into the raw table, that exact same insert, the hash of the insert that gets created, will trigger the materialized view instantaneously. And then that materialized view will go and run its aggregation, its summing, whatever the materialized view is doing from that particular point in time, but it will run that instantaneously. You don't have to read from another table and then write to another table. You're basically getting triggered as the data is getting written into the particular source, and that materialized view will get triggered to be able to create that aggregation. So very powerful to be able to use materialized views in ClickHouse. So yeah, from an interface perspective as well, so ClickHouse has a HTTP interface for management. You can also ingest data, but you can use that as a management function. But it's also got its own native TCP protocol as well, which is quite powerful. It's all written in C++. They're very fast. JDBC, ODBC connections, client libraries, Go, .NET, Python. Seeing a lot of Go as well lately. And yeah, things around data ingest, I think we spoke. Yeah, Kafka, S3 are probably the two most common ones that we see these days with ClickHouse around data ingestion. Query editor, things like dbeaver, Visual Studio is a really good integration there as well. And from a visualization perspective, things around Grafana are typically being used for observability and security use cases. We also see things like Superset, Metabase for BI, and BI type use cases and analytics use cases. And just from an architecture perspective, so ClickHouse has a concept of a server. So a server has, you can run everything on a single server, and it scales really well both vertically and also horizontally. So if you scale out horizontally, you can choose to have the table replicated across 4 different servers in this particular case, or you can have sort of multiple shards or replicas split across different servers there as well for redundancy and availability, high availability there. Each of the servers have their own data store, so their own storage attached to the particular server. And there's a coordination layer which is called ClickHouse Keeper that keeps the coordination of all the tables and the servers and the table statements that live within there. That's your typical sort of architecture for ClickHouse. I just want to touch on one more. So ClickHouse Cloud has a cloud native based architecture where it's almost like a shared nothing type architecture. Essentially, the servers and the storage have been decoupled. So the storage is backended onto an S3 object store with an intelligent caching layer sitting above that. The servers can scale up, scale down, or even turn off if you don't need them. There's a period where there's a shutdown period. If you're not using your servers, they will shut down automatically, but then spin back up when you need that and will have full access to your data. And then there's obviously a load balancing proxy feature there as well. And yeah, so last bit was the control plane UI sort of piece there, user management, service monitoring, and all the features and functions that you would get from a cloud service.